Hello out there, welcome today. So the focus of this lesson today will be focused on application of counting principle. What is application of counting principle? Okay. So previously we've learned the counting principle, the fundamental counting principle. How many ways can we arrange boys and girls in a cinema if there's 7 chairs in a row? Something of that nature. And we've looked at examples where we look at car registrations in Gauteng and how many car registration we can form in Gauteng. And remember that vowels and Q was not used. So now this section, we're going to look at how can we really apply that? Why is counting principle so useful? But the application will be based on probability. Okay, that's what counting principle. And remember to work with us there, have a pen and paper, and really focus and push some of the problem with us. Okay, fantastic. Okay, now, what is the question? The question is, what is the probability of contracting COVID-19 at school? Okay, so the likelihood of getting COVID-19 at school, if you social distance and you're using a mask, that's very low. But to actually calculate the likelihood of that, you will need to collect data and see how many people are actually getting COVID-19 and when one can estimate the likelihood of getting COVID-19. Okay, fantastic. Now, let's look at some of what you're going to focus on. We did say we're going to look at application of counting principle, but we'll look at problems. Relating to probability, we'll revise the fundamental principle of counting. Then look at arrangement and example and repetition and choice with repetition. It's very important that you have mastered your counting principle because you're going to use the fundamental of counting principle to calculate some probability. So that's application of that. Are we together? Okay. So let's look at some of keywords. What is arrangement, counting, and repetition? So arrangement is when I arrange, sort things out, that's arrangement. And counting in this, what are we talking about? You know how to count, we can count from 1 to 10. But that's easy, but if you have a bigger set, it can be difficult to count. So hence, we use the fundamental of counting principle. And when we talk about repetition in the counting context, if I have to form a password using 3-digit numbers, I can use 555 as my password. But what if I don't want to repeat digits? I cannot use 555. I can use, for example, 542. I've not repeated any digit. So that's what we talk about repetition in counting principle. Great. So what is a sample space and what is event? A sample space and probability, if, for example, I have a coin, if I flip a coin, there are 2 possible outcomes. What are those outcomes? Is it tail or head? So tail and head are my sample space. And what is the size of sample space? Is 2 in a class of boys and girls. If in that class there's 30 of you, the sample space is the sum of boys and girls in that class. Are we together? That's the sample space. Then an event, we'll talk about, when we talk about an event, let's go back to an example of a classroom with boys and girls. So the probability of choosing a girl, it's an event. The probability of choosing a boy, it's an event. Are we together? That could be an event. Fantastic. So let's look at some of our probability we've done previously, okay? Inclusive, mutually exclusive event. What is that? So if we have 2 inclusive event, which is A and B. It's an event. We've defined what is an event. So the 2 events have a common outcome. Are we together? There's a common outcome between the two events. If we look at subjects, so I could be taking, let's say, maths and science, okay, something of that nature. There's an intersection between the common thing, the two events. So this would be something like the probability of A and B. So the probability of A and B is the probability of A plus the probability of B minus the intersection. Are we together? So that will be mutually exclusive events. So if we have two mutually exclusive events, A and B have no common outcome. Are we together? So this part becomes 0. Are we together? Okay. So one example is taking physical science and math literacy as a subject. Sometimes that is not allowed. So you can't take, two cannot happen simultaneously. Okay. So if that's the case, which is exclusive, if this part becomes 0, then the probability of A or B is probability of A plus the probability of B. Great. And what about complementary events? Events which are mutually exclusive events that together contain all outcome in the sample space. For any two complementary events, so this means not, the probability of not A, it's 1 minus the probability of A. Or also the probability of A is 1 minus the probability of not A. What does that mean? If the probability that it will rain today is 50%, what is the probability that it won't rain? It's 50%. It's 100% minus 50, which gives us 50%. So the two events are complementary. Okay. What about two events which are statistically independent? So events which are statistically independent, the probability of A and B is the same as the probability of A times the probability of B. And statistical independent, remember, the probability of A occurring does not affect the probability of B occurring. Okay, those are statistical independent. Okay, so then from there, we have to remember our fundamental principle of counting. Okay, what does the fundamental principle of counting say? If there's M way of doing something and N way of doing something, then there is M multiplied by N ways of doing both together. Okay. So the fundamental counting principle states that if there are N A outcomes in an event A and N B outcome in event B, then there are NA multiplied by NB outcome in event A and B combined. Are we together? Fantastic. So we've indicated that we'll focus on application of counting principle. Okay. So application of counting principle in calculating probabilities. What is probability? Okay. How do we calculate probability? Let's look at this following definition. Okay. So to determine the probability that an event occurs when the total number of arrangements of a sample space S. So S is the sample space S. Are we together? And the total arrangements for the event E, so those will be the total arrangement, which is E, are very large. We will use the fundamental counting principle to determine the total numbers of arrangement. So we will use, so we know that if we have a die and we roll a die, what is the probability that one will occur? Because there's only one, the event is one. There's only one in a die. But the sample space is 6 because we have 1, 2, 3, 4, 5, 6. So the probability will be NE, which is 1, and SNS, which is the total sample space, which is 6. It will be 1 over 6. So we have used counting, but a simple counting, because I can count how many, the sample space in a die, and the event in a die. But if you have a large number, it will be difficult to count. We'll have to use the fundamental principle of counting. Okay, so we will use the same formula, but what will differ, we'll combine this with fundamental counting principle. Okay, guys, when we come back after this break, we'll look at how we really apply the fundamental principle of counting and probability theory. See you shortly.